In this video, I'll do the homework from section 2.1, the organizing qualitative data. So that's the topics. Um, let's start with the question number 1. This is the fill in the blank questions. A frequency distribution lists the of occurrence of each category of the data. Frequency distribution lists number of occurrence. So I got to pick the number from the drop-down menu. Here's the answer, number of occurrence of each category of the data, while the relative frequency distribution lists the proportion, proportion of the occurrence. So there's two things here. One is frequency distribution, other is relative frequency distribution. Frequency distribution lists the number, how many times that data occurs, number of occurrence, and relative frequency gives you proportion of the occurrence. Notice that proportion is proportion is the value always between 1 and 0. Okay, so if you talk about the proportion, is the decimal number like 0.67. That's the proportion, and you can think this number as a percentage as same as 67%. As a percentage, you can say 67%. As a proportion, you can see 0.67. So that's the question number 1. In the relative frequency distribution, what should the relative frequency add up to? So if you have a relative frequency distribution, the relative frequency are add up to 1. Okay, but if you look at the second choice, B, the add up to total number of observation, that is frequency. So frequency add up to total number of observation, that means how many data on the data set, but relative frequency add up to 1. Question number 3. This is the definition question. What's the bar graph? And what is a Pareto chart? So if you read all the options here, and you can easily see the definition of the bar graph. The bar graph is for qualitative data, where the horizontal axis represent the data, and the vertical axis represent the frequency of the data. So, or relative frequency. Okay, so bar graph looks like this. This is the bar graph, how it looks like. Just simple drawing here. So, and in the bar graph, each rectangle has different height. The height is either frequency or relative frequency, because this way is the frequency or relative frequency, and each height has the same, each rectangle has the same width. That means this distance here and this distance here, this distance here is the same width, and they never touch each other. Okay, so that is called bar graph. So if you look at the option here, C is the option, correct option. Bar graph is a horizontal and vertical representation of the frequency and relative frequency of the categories. Remember, the data is also called category here. CTGORI, categories. And the height of each rectangle represents the category's frequency or relative frequency. That's the bar graph. Pareto chart is the bar graph with all the bar in decreasing order. That's Pareto chart. For example, I can draw the bar graph here. This way is a data, category of the data, and this way is frequency or relative frequency in the vertical axis. Let's draw the bar graph where each bar here has the same width but different height, but height must be in decreasing order. So if you look at this bar graph, which is called Pareto chart, okay, but this is not the Pareto chart because the bar is not in decreasing order, but this is the Pareto chart. Question number 4. This question is based on the pie chart, and there is 4 category of the data: small, medium, large, and extra large. Size of the beverage, the customer order in the fast food restaurant. And again, pie chart is already given to you. You just find the information from the pie chart and you answer the question A, B, and C. So obviously you can see that the yellow represent large, and which is 56% customer order that large beverage, and so on. And if you add all these percentages, must be added to 100%. That's supposed to be, and it is. So now first question is, what is the most popular size? What percentage of the customer choose this size? So most popular size here is large, which is 56%. So the answer is large, which is 56%. Also, you got to answer what percentage of the customers choose this size. Look at here, what percentage? Okay, if the question say what proportion, PROPORTI1, sometimes you might actually as a proportion. Proportion is going to be 0.56. Okay, just extra information for you. Next question B, what is the least popular size? And you look at the here, extra large here is only 9% customer choose that extra large. So extra large here is least popular. The percentage is 9%. But if you question asks you find the proportion is going to be PROPORTI, and proportion equals to 0.09. But you got to find the percentage, so you should write 9%. So that's how you do part B. Part C, what percentage of the customer choose medium-sized beverage? So medium-sized beverage 15%. So answer is what percent of medium-sized beverage? So answer is obviously 15%. Okay. Question number 5. In a poll, a random sample of 2,163 adults 18 and over was asked, when you see an ad emphasizing that product is made in your country, are you more likely to buy it or less likely to buy it, or neither, more or less likely to buy it? So to find this answer of the question, people are asked as a survey, 2,163 adults, and results are given here. So if you look at here in this bar graph, CC more or less neither. So in that age group 18 to 34 years old, that many proportion, remember the relative frequency is same as proportion. Okay, again, relative frequency is same as proportion. Let me tell you that. So in more likely to buy if they see the ad is 0.41. So 0.41 as a proportion is same as 41%. So in other words, in that age group, the people between 18 to 34 years old, 41% people more likely to buy the product if they saw the ad that is made in their own country. So this is the percentage also. So 0.41 is proportion, but 41 is percentage. Similarly, in that age group, 18 to 34 years old, 0.51 proportion of the people want to buy less likely. So 0.51 is same as 51% as a percentage, and 0.08 as a proportion, which is same as 8%, is neither. So if you add 41, 51, and 8, you get what? Total added to 100%. At 200%, obviously. So similarly, you have a other group of people who less likely to buy it, more likely to buy it, or neither. So you have this frequency distribution, relative frequency distribution chart here. This is called relative frequency distribution because this way you have a category of the data, and this way you have a relative frequency. So let's answer the first question here. What proportion, the question actually, what proportion of 18 to 34 years old responded are more likely to buy when made in their country? And what proportion of 35 to 44 years old, like next age group, responded are more likely to buy when made their country? So let's see, more likely to buy here, which is given by blue, 0.41 in 18 to 34, 0.54 and 35 to 54. So first question answer is going to be 0.41, and second question answer is going to be 0.54. Remember that this is the second age group, okay? So it's a proportion. So you got to put the decimal between 0 and 1 as answer. So that's the first question A. B. What age group has the greatest proportion who are more likely to buy? More likely to buy, you look for the green bar, and if you look at the table or frequency distribution, look at here, see 55 plus year people are more likely to buy, and that's the age group who more likely to buy if their product is made in their country. So answer is going to be D. Okay. Which age group has a majority of the respondent to are less likely to buy when made in their country? I'm looking for less likely to buy chart, and I got to find the age group. Okay, so less likely to buy, and age group here is let's see, age group here is majority here. Obviously you see that the green area less likely to buy here, 0.51 in their age group, less likely to buy, 0.41 here, 0.34 here, 0.24 here. So in that age group 18 to 34 years old, majority of the people are less likely to buy. What is the apparent association between age and likelihood to buy when made their country? So you're comparing age with the likelihood to buy when made their country. So if you look at here, and if age increases, right, people are more want to buy made their country. See here, so 0.41, 0.54, 0.60, 0.72. So if age increases, people are willing to buy the product made in their country. So answer is A here. As age increases, so does the likelihood to buy a product made in their home country. Suppose a survey, the question number 6 by the way. Question number 6. Suppose a survey of adults and teen aged 12 to 17 in a certain country was conducted to determine the number of texts sent in a single day. So how many texts adult or teen send on the single day is given in this table here, and you see the number of texts range here. None of the text, between 1 to 10 text, between 11 to 20 text. So these are the number of text message ranges. Okay, so 100 plus text is going to be the last row here. So 173 is the adult who send none of the text in single day, and 11 is the teen who did send none of the text on the single day. So that's how this chart looks like. You see the table. So and the question here is, we construct the relative frequency distribution for adults and relative frequency distribution for teens in A and B. Okay, so and to construct that, let's find the how many total adults are in survey. So if you add all the totals here for total adult, if you add 173, 980, 257, 253, 126, 161, if you add all these adult numbers, you'll get total number of adult in the survey is 1950. So now how many adults send none of the text on the single day is 173. So to find the relative frequency of these adults here in the first box here, you divided 173 divided by 1950. Okay, and you divide it and round your answer to the 3 decimal places as needed. You get 0.089. Okay, again you select the instruction down to 3 decimal places. Similarly, what's the relative frequency of the adults who send 1 to 10 text messages in the single day is, you divided 980, which is the number of adults who send the text between 1 and 10, divided by total number of adults in 1950, you get 0.503 if you round it to 3 decimal places. Similarly, you find all of the relative frequency, and then if you add all this relative frequency, there's supposed to be 1 in total, but you don't have to add it, but you can check your answer. So this is the question number part A. I'm not going to do rest, you do other similar. Now let's find the relative frequency distribution for the teen here. Okay, so let's find how many total teen in the survey. So you add all the teen here, all the teen. If you add all the teen, how many teen gonna be total teen between the age group 12 to 17, by the way, gonna be 652. Okay, so to find the relative frequency of non text message is going to be 11, which is number of teen who send none of the text messages, divided by 652, the total number of teen in the survey, and again rounded to 2 decimal places, it gives you 3 decimal places, 0.017. Similarly, to find the other number of text group from 1 to 10, you divide how many teens send the text message between 1 to 10, 143 divided by 652, total number of teen here, that gives you 0.219. okay, 219. So similarly, you do all and find the relative frequency of each range of the text messages for teen and adults. Okay, so now let's choose the correct graph. If you look at the graph carefully, you see this way is the relative frequency, this way is the number of text, and if you look at the matching here, let's say first one is none. Let's see which one match here. I think the C match here. See, non-relative frequency is going to be 0.089. Here is close to 0.10, right? This is 0.089 is pretty much close to 0.09, so it's going to be this. And for red one, which is teen relative frequency, is going to be 0.017. It's pretty close to 0.02, which is going to be this. So if you find the relative frequency of each number of text and look at the match your table with the graph, this must be the right answer, C. Okay. For part D, you compare the texting habit of adults and teen. So if you look at the this correct graph here, and you see that number of texts is increases, a teen are sending more text. So see, number of text messages increases, teen relative frequency is more. That means percentage of teen who is sending text messages is more. So the answer is, let's read the option here. If you read the option, the answer must be C. Adults are more likely to send few texts per day, while teens are more likely to send many texts per day. That's the answer. Okay, for part D. The Accompanying table shows the movement of the Walt Disney Company's stock for 30 randomly selected trading days. Up means stock price increases in value for the day. Down means stock price decreases in the value for the day. And no change means stock price closed at the same price it is closed for the previous day. So complete part A through E. So you got to find the data first. So data is here, the movement data, and this 30 data because they are the movement for 30 days. So how many days it goes down, you have to count to find the frequency of down. So let's see, 1 down, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there is 16 day the stock price goes down. So the frequency of down is 16. So the down has a frequency 16. What's the frequency of no change? Similarly, you count for no change. There is 2. You can count it. And for the up, you count how many up there. It's 12. That's the frequency of up. So if you add them, obviously this is going to be total is 30 because there is 30 days movement. In other words, there is 30 data. Remember that this data is qualitative data. Okay. Now find the relative frequency of each movement, and you round your answer to 3 decimal places as needed. So let's find the relative frequency of down. So what's the frequency of down? 16. So 16 divided by total is 30. And if you divide 16 by 30 and round it to 3 decimal places, you get 0.533. So 0.533 is relative frequency of down. Similarly, relative frequency of no change is going to be 2 divided by 30, which is going to be 0.067. And the relative frequency of up is 12 divided by 30, which gives you 0.400. And again, if you add them, the total is going to be 1. You don't have to do that, but to see it, the relative frequency add up to 1. That's the relative frequency distribution. And that this one is a frequency distribution. This is relative frequency distribution. Now let's graph this frequency relative frequency distribution on the bar graph. So if you see out of 4 choices, the correct bar graph going to be for this frequency distribution is D. Obviously you can see that for the down frequency is 16, for no change frequency is 2. See, this way is frequency. For up frequency is 12. So this is the right frequency bar graph. So for other question, for D, looking for relative frequency bar graph. Rather than frequency on the vertical axis, you're going to have relative frequency on the vertical axis, and the horizontal axis has a category of the data. So, and for this question, if you look for correct graph, obviously looks like D here is the right graph as well, because you see that for the down, relative frequency is 0.533, which is going to be this one. And so you can check relative frequency table with this bar graph and see which one matches. So answer must be D. Finally, pie chart is not difficult, and pie chart is also D here. Now you guys always see that for the down you have most frequent, so this has a bigger circle, bigger section of the pie, and similarly other next biggest is up, which is 16 frequency, and the red one is no changes, only 2 frequency. This is the correct pie chart. Okay, so you'll find it just looking at the frequency for each category of the data. So this is the question number 7. All right, question number 8. This is similar to 7. you have a uh, you have a qualitative data, which is blood type of the 15 patient. It's sample data of 50 patient. So these are the 50 data here, 50 data, which is qualitative data. And you got to find the first frequency distribution. So how many has a blood type A? You guys count how many has blood type A, saying 1 2 3 4 like this. So you'll get frequency of A blood type is 19. That means 19 times A repeats on this data set. Similarly, relative frequency of AB gonna be 3. Relative frequency of B, you count how many B on this data set, which is gonna be 7, and relative frequency of O gonna be 21. Now obviously if you add this total must be 50. You don't have to, but if you see that, if you're adding this, all frequency gives you total number of data, which is 50. So this is the frequency distribution. To construct the relative frequency distribution, we did before, you divided each frequency by total to get relative frequency. So to find the relative frequency of blood type A, you divide 19, what is the frequency of A, by total 50. And you rounded your answer to oh, it doesn't tell you how much decimal places you need to round. It just tells you simplify your answer. You just write the exact answer after you divide. You get 0.38. Okay, so relative frequency of A gonna be 0.38. Relative frequency of B gonna be 0.06. Relative frequency of AB gonna be 0.06. Relative frequency of B gonna be 0.14. Relative frequency of O gonna be 0.42. And if you add them, you don't have to, the total must be 1, because relative frequency add up to 1. So this is called relative frequency distribution. So next question say, according to the data, which blood type is most common? So the most common means which has a more relative frequency or more frequency, which is going to be O. So answer is O is the blood which is most common type. So next question is, according to the data, which blood type is least common? That means which has a least number of frequency going to be AB, which is least common, which is AB. So you guys find frequency, relative frequency distribution, and you answer the question about which is most common, which is least common. So part E says, use the results of the sample conjecture of the percentage of the population who has O type blood. Is this example of descriptive or inferential statistics? So you got to look for what is the percentage of O blood type. Remember that proportion is percentage. So 0.42 is a proportion. Proportion, also called relative frequency. Relative frequency. In other words, this is same as 0.42 is same as 42%. So if you make a conjecture based on this sample data, and you say that, okay, in general 42% people has a blood type O, that's how you conject. So this is called inferential statistics, because you say in general about the population that 42% of the people has a blood type A. So this is the example of inferential statistics, because you say something about the population, you infer the population value, which is 42% of blood type O. That is called inferential statistics. Okay. Contact part F. Contact a local hospital and ask them the percentage of the population of the blood type O. You make a conjecture that 42% has a blood type O because of this 50 people sample. So if you contact local hospital and ask the blood type O, what might the result differ? Okay, and if you read the option here, um, maybe A makes sense. Let me read A for you. The results might differ because there is always variability because the individual in the survey may not exactly reflect the makeup of the population. That could be the right answer. And if you look at the other option, that is slightly different. And there, for example, the results might differ because certain hospitals only treat patients if they have blood type O. That doesn't make sense. Part C, the results might differ because the results from the study are not likely to be similar to the actual patient. That doesn't make sense either. So answer must be part A for F. And for G, you guys need to draw the frequency bar graph. We already did one for this question number 7. I'm not going to do that. So draw the frequency bar graph, and again draw the relative frequency bar graph, and also finally you draw the pie chart for the same data. We did that before, so you should be fine. Question number 9. Consider the information in the why we cannot lose weight is the chart that's shown in the magazine style of the graph. Would the information provided be organized into the pie chart? Why not? So each category of data here, metabolism, too slow, down exercise, and this 4 category of the data has each percentage. But if you look at the each percentage and the top, this add up to more than 100%. That means you cannot put or you cannot organize this information into the pie chart. So answer is B. No, we cannot organize because the percentage add up to more than 100%. That's the 9. So question number 10. Determine that statement is true or false. So if the question asks you, is this the true formula for relative frequency? So this is not. This is the other way around. Has to be reciprocal. Has to be frequency divided by sum of all frequency, going to be relative frequency. This is obviously question number 10 is false formula. Question number 11. The bar graph shows the number of tickets sold each week by the garden club for the annual flower show. Okay, so number of tickets sold in each week: 1 week, 2 week, 3 week, 4 week, up to 6 week. How many tickets sold here? So the question tells you in which approximately how many tickets were sold during the week number 6. Week number 6, you can see here, you approximate the number is less than 20 tickets. How much tickets going to be sold then? If you look at this one, obviously this looks like you have an option here. Obviously 19 tickets sold on week 6. Question number 12. Retailer always interested in determining why customers selected their store to make a purchase. A sporting goods retailer conducted the customer survey determine why is customer shopped at the store. The results are shown below. Find the percentage of the customers responded that the merchandise was the reason why they shop at the store. Round to the nearest whole percent. So you're looking for percent. To find the percent, you got to find the proportion. So to find the proportion, how many total are in the survey? So let's see, prices. There's 20 people. The frequency of prices, because of price, because of merchandise, 30 people. Because of convenience, 10 people. Because of other reason, 10 people. So how many people are in the survey? Altogether 20, 30, 50, 60, 70. 70 people are in survey. That means 70 people did the survey. Out of 70, how many people choose the reason is merchandise? So merchandise is let's see, merchandise here is 30 out of 70. Okay, and if you divide 30 by 70, you get 42.857, and if you round it to the nearest whole percent, this excuse me, this is going to be 43%. So answer is going to be D, which is 43%. Question number 13. Accompanying double bar graphs illustrate the revenue for the company for the 4 quarters of for the year for 2 different years. Use the graph to answer the question. So there is a first this is each quarter revenue in the first year and second. For example, this dark is first quarter revenue. This dotted bar is second year first quarter revenue. So first quarter, second quarter, third quarter, fourth quarter revenue in each year. So dark represent first year, the dotted bar represent the second year. So the question tells you what in what quarter the revenue for the list of year one. So look for year one. Year one is dark bar. So list revenue in year one. You're looking for year one. So the dark is year one, and what list revenue going to be in here? So this is the list revenue. That means in second quarter. In the second quarter of first year, the revenue is list. So answer is going to be D. The second quarter, you can see second quarter is the list revenue for year one. Remember the other quarter, year one has what? More revenue, which is dark is year one. 14. Give the accompanying bar graph. The Pareto chart that would best represent that data should have the bar in what order? Remember that Pareto chart has to have the bar in decreasing order. So to make a Pareto chart, D must be first. D must be first bar graph that is drawn must be on the left, and next bar must be A, which is next higher, and the next must be E. So if you look at the option here, your answer is going to be D, A, E. Next has to be C, next has to be F, and the rightmost bar must be B. So this C as an answer. So to make a Pareto chart, this bar must be drawn in this order: D, A, E, C, F, B order. Question number 15. The pie chart shows the percentage of the votes receiving by each candidate in the school council president's election. Use the pie chart to answer the question: who received the fewest votes? If you look at this pie chart here, this this slice of the pie is the smallest pie, so this represents the Jim. So Jim got the fewest vote, which is obviously 15%. Okay, that's the answer. Answer is B, Jim. Thank you for watching.